Okay, so we're going to do a couple more word problems, but before we do, I just want to give you a hint. The last three were all consecutive, even or consecutive integers or consecutive odd integers, so it was really clear what the variables should be because we've already talked about that. But if you have two values that you're trying to find, like sometimes length and width, or sometimes you're looking for two different numbers and it's hard to tell which one you should find, and it may be unclear for you to know which unknown you should make your variable be equal to. Then what I want you to do in that case is find the comparative statement. What's where a statement is comparing one of your variables to the other. Then what I want you to do is to let your variable be equal to the unknown that the statement is being compared to. It's often written as the second variable mentioned in the sentence. For example, if I have this problem, the area of a rectangle is 28 square feet. The length is 1 foot less than twice the width. What are the dimensions of the rectangle? We have three sentences. The first sentence talks about area and gives you some information. That is not comparing one variable to another. The second sentence says the length is blah 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 to the width. The length is being compared to the width. I know there's a lot of words in there, but I am comparing the length to the width. Do you see how this is the comparative statement? Okay. So it says let your variable be equal to the unknown in the statement that's being compared to. The length is blah 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 to the width. Okay, the length is 1 foot less than twice the width. It doesn't really matter what all that junk is. If I'm just trying to figure out what the variable is, I am going to let x be equal to the width. It's the one that mentions second in the sentence, and it's the one that length is being compared to. So I'm going to let x equal my width. This is the easiest way to do it. Technically, you could do it let x equal the length, but it's so difficult to find out what the width is in terms of length if the length is being compared to the width in this case. So if you let x be equal the second thing mentioned, or the thing that's being compared to, then when I go back and try to figure out what the length is, it says the length is 1 foot less than, that word than, remember what that word than says? The minus 1 goes in the back, twice the width, 2x less 1. Okay, now we're not going to actually finish this problem till later. I was just trying to get you to understand that the length is 1 foot less than twice the width is the comparative statement, which is going to help you figure out what the x is. So let's practice this on the next problem. One number is 3 less than twice another number. The product of the two numbers is 20. What are the numbers? Okay, so notice I'm looking for two things. Numbers. Okay, so because there's two things, I don't know which one I should make x be equal to. So what I'm going to now look for is the comparative statement right here. Clearly the first sentence is saying that one number is being compared to another number. Well, which one should be our x? Well, x is going to be the another number. It's the one mentioned second. So this is going to be our x. So we're going to let x be equal to this first number, okay? So now that I have that comparative statement and I know x is this guy, I need to write the other one. So the other number, or one number, is, I already have that second number, is, okay, 3 less than. What does than mean? Than means I'm going to switch my order and the minus 3 is actually go in the back. 3 less than twice another number. So twice the x, twice this x, 2 times this x, less 3 is the second number. Okay, that was step 1. Step 2 says if you have a picture you can draw it, still no picture. Step 3 says write the equation. Well, we've already basically used up everything from that first sentence. So I'm going to keep reading from the second sentence on and see if I can't write an equation. The product, okay, stop. As soon as you get to the product, we stop and write a multiply. And then we have to go back to read because I have to figure out what the heck I'm multiplying. And what is it that I'm multiplying? Well, the two numbers. Well, what two numbers are we talking about? Well, the two numbers are the numbers that we talked about in the previous sentence. So you have to look at this all as one little paragraph. The product of the two numbers, by the way, the two numbers were the things that I just mentioned in the last sentence, which I've already decided are x and 2x minus 3. These are my numbers. Is. What does is mean? Is means equals 20. And now I have my equation. Step 4 says to solve that, and you guys know how to solve this now. We have 2x squared minus 3x equals 20. Subtract 20 from both sides to get 2x squared minus 3x minus 20 equals 0. I'm going to try to factor it, because if I can factor it, I prefer to do that. 4 times 5. Let's say 1x and 2x. I don't want the 2 and the 4 next to each other, so I'm going to put the 4 up here. That gets me 8 and 5, and on my first try I can use two different signs, that's what this says, two different signs, and add to a negative. So I put the negative on the bigger number, the bigger product, and that slips in. Make sure you're putting the negative on the bigger product out here, the 8 and the 5, not comparing the 4 and the 5, but 8 and the 5. So I'm going to get x minus 4 times 2x plus 5. Set each of those factors equal to 0. So I have x is equal to positive 4. And then negative 5 halves. So I have two numbers here. But are these the two numbers that my question is asking for? Well, still not quite. What did I solve for here? I solved for x. And what is x? X is merely the first number. So I also then need to find its corresponding second number. Same thing over here. If I found the first number here, I need to find his corresponding second number. Because I'm solving for x, I need to figure out what the second number is. So the second number is defined as 2x minus 3. But I know what my x is, don't I? I'm going to stick in 4. So 2 times 4 is 8, and 8 minus 3, my second number should be 5. So 4 and its corresponding second number, 5, should possibly be an answer. Let's see, negative 5 halves. So my second number will be 2 times x minus 3, but my new x is negative 5 halves. Well, this isn't too bad because the two 2's divide out, and I'm getting negative 5 minus 3, or negative 8 as my second number. So the other two pairs of numbers are 5 halves and negative 8. So these are my two possible sets of numbers. Step 5 says to check. I'll do that check over here. Okay, so our 4 and 5 work. Let's check 4 and 5 first. Is one number 3 less than twice the other? So if I take 4 times 2, twice that number 8, less 3, is that 5? Yep, that first sentence works. Is the product of my two numbers equal to 20? Yep, that works. So 4 and 5 seem to work. Let's now check negative 5 halves and negative 8. Alright, if I take one of those numbers, negative 5 halves, and I'm doubling it or twicing it, less 3, that gets me negative 5 minus 3, or negative 8. Okay, that first sentence works. Is the product negative 5 halves times negative 8? 20, I don't know. Negative times a negative is a positive. 5 times 8 is 40. 40 over 2. That is 20. It works. So both of these answers do work. I was able to check. Notice I checked with my words and not with my equation. I actually find it easier to check with the words, and it's more thorough. On this next problem, we have 3 times the square of a number is 6 less than 9 times that number. What is the number? So when we're first trying to find what x is, you usually look at the last sentence or directive or question. It says, what is the number? Well, we don't know what the number is, so we're going to let x equal the number, the unknown number. It's really important to note here that we are only looking for one number in this particular problem. One number. It doesn't say plural numbers here, it says one number. So unlike the ones that we've done before, it says what are the numbers, what are the two consecutive numbers. In this case, we're only looking for one number, one unique answer to solve the problem. So just pay attention to that, okay? So we don't have let x plus 1 be the second number or anything like that because we don't have a second number, we're only looking for one number. I can't really draw a picture on this one, so let's go ahead and try to write the equation. I'm going to go ahead and read this. It says 3 times the square of a number. So 3 times mean I'm taking 3 times the square of a number. Well, the number that we don't know is x squared. So 3x squared is, now is means equals, 6 less than, remember that word than does. Than switches the order, so when I have 6 less than, I'm going to have something minus 6. And then 9 times the number. The number again is the x. So we have 9 times the number x less 6. So this is my equation. It doesn't look quite in the standard form, so what I'm going to do is subtract 9x and add 6 to both sides so that I can get one side equal to 0. We have 3x squared minus 9x. Notice those don't add because one's an x and one's an x squared. Plus 6 equals 0. Now I need to solve this. It looks like there's a GCF here, so I'm going to factor a 3 out. It's going to make our factoring a whole lot more simple. It's now a trinomial, an easy trinomial because there's a 1 in front now. So I know that I have to have an x and an x in the front. We're looking for two numbers that multiply to a positive 2, yet add to a negative 3. Because it's positive, my signs have to be the same, meaning they both have to be positive or they both have to be negative. In this case, they both have to be negative in order to add to a negative 3. So negative 2 times negative 1 is positive 2, multiplies to positive 2. And negative 2 plus negative 1 adds to a negative 3. So now this is factored. I set each factor that has a variable in it equal to 0. So this factor, 3, doesn't have a variable in it, so setting it equal to 0 is not helpful. If I did set that one equal to 0, it's clear that 0 is never going to equal 3, so there's nothing there to solve. So even if you did, it's not going to cause you too much problems. So we have x equals 2 and x equals 1. Really, or x equals 1. Now, remember from back in the beginning, we said let x equal the number. We said we only need one number, but here I have 2, which means I might have 2 distinct answers that could solve the problem. So let's go ahead and check. Let's check x equals 1. That's the unique distinct answer. So if we try 1, what happens here? Well, 3 times the square of a number, so 3 times 1 squared is 6 less than 9 times the number. So 9 times my number 1 less 6. Let's see if that actually works. So 3 times 1 squared is 3. 9 times 1 is 9 minus 6. It truly does work. 3 equals 3, so that one does work. Well, what if I was to check x equals 2, totally independent from x equals 1? Notice these are not two answers that go together. It's not like a pair of answers like we've had in the last couple of problems. This one, x equals 1, works. Now let's find out, does x equal 2 also work? 3 times the square of my number is 2, is supposed to be 6 less than 9 times that number. So 3 times 4 is supposedly equal to, 9 times 2 is 18, 18 minus 6. Well, look at that. It also works. So I have 2 independent, unique answers. Both of the answers will solve my problem, my word problem, but they don't go together. They're 2 unique sets of answers. I just want to make sure you understand that it's not a pair of answers. And that concludes this lesson.